Question 3, this is from an exam 2. You can tell because it's not multiple choice. And this is another transition matrix sort of question. There's a few parts to this one, so let's go through it bit by bit. This time we've got a new industrial site established at the beginning of 2011, and there were 350 staff at the site, right? So that might be some key information. Often it's good to just have a highlighter with you as you work through these sorts of questions, so you can go back to key information. The staff comprised 100 apprentices, 200 operators, and 50 professionals. Okay, so again, values are often going to be really important for us in these questions, so we can pick those out. At the beginning of each year, staff can choose to stay in the same job, move to a different job at the site, or leave the site. And the number of staff in each category at the beginning of 2011, which were those numbers up here, is given by the matrix S 2011 equals 100, 250, 0. All right, so you can see that that's just a summary of which people were in which positions, and obviously at the first year, there's no one left yet. Right, as in nobody has left the job site yet because they've just started. So that's why that last number is a 0. The transition diagram below shows the way in which the staff are expected to change their jobs at the site each year. Okay, so we've got a transition diagram. We're used to seeing these, which has percentages all over them. First question says, how many staff at the site are expected to be working in their same job after 1 year? In other words, how many of them, if they were apprentices, are still apprentices the next year? Right, now this seems like it's going to be a question where we use a transition matrix, but it's actually not, because this is really specific to certain numbers within, I guess, these state matrices and within the percentages. So we don't actually want to know how many people are apprentices and operators and professionals. We just want to know of these original numbers, how many actually stayed in the same job. So let's start with the apprentices. The apprentices, there were 100 of them, right? And from this diagram, you can see that 70% of the apprentices stay as apprentices from 1 year to the next, okay? So we want to work out 70% of 100. And the way we can do that is to do 70 over 100, right? Times 100. So that number there is the apprentices. Then let's look next at the operators. We had 200 operators, right? And from the diagram, we can see that 80% of operators stay as operators the following year. So we have 80% of 200, so 80 over 100 times 200 plus, and then the other one was the 50 professionals. And you can see from the diagram that 90% of the professionals stay as professionals the following year. So 90% of those 50 people will be in the same job, right? So this first number is going to be the number of apprentices who stay in the same job the next year. Second number is going to be the number of operators who stay as operators the next year. And the third number is going to be the number of professionals who stay as professionals after 1 year. All right, so those three numbers added together will give us our answer here. Now, you might be able to do some of those calculations in your head, and that's fine, but if you're not sure, go to your calculator. All right, 70 divided by 100 times 100 is, of course, 70. 70% of 100 is 70. 80 divided by 100 times 200 is 160. All right, so 80% of 200 is 160. And 90 divided by 100 times 50 gives you 45, because 90% of 50 is 45. And then we add those three numbers together. 70 plus 160 plus 45 is 275. There are 275 staff who stay in their same job from the first year to the next year. That's actually a really tricky question, right? And like I said, it's not one that we could use a transition diagram, a transition matrix for, because the transition matrix would just tell us the total number of people in each job. It wouldn't tell us anything about the number of people who stayed in their same job from 1 year to the next. Tough question to start this one off. Okay. In part B, they actually give us the transition matrix, and they've said that we've got, these values from this year to the next year, and they've got the percentages from the diagram shown in this matrix. It says, explain the meaning of the entry in the fourth row and fourth column of the transition matrix T. Well, the fourth row and fourth column is this element here. All right, so we need to know what number we're looking at to start with. And that number's a 1. Now, what that's saying is we've got people who have left. Remember that L stood for people who leave or people who have left. And what this is saying is if people who have left this year, 1 or 100% of them will be left next year. In other words, once people leave, they don't come back. All the people who have left continue to have left, right? Which is a funny way of thinking of it. So what that really means is that no workers return to this site after they leave. So you could say it a couple of ways. You could say all workers who have left this, now let's use they do use the word site, left this job site, this is probably a funny way of saying it, isn't it? Probably they stay left. In other words, no workers leave, then return. In fact, that's probably a better way of saying it. No workers leave and then return. Okay, if staff at the site continue to change their jobs in this way, the matrix SN will contain the number of apprentices, operators, professionals, and staff who leave the site at the beginning of the nth year. Use the rule SN plus 1 equals T times SN to find S2012, right? So remember that S2012 will just equal T times S2011. And in this question here, it was already established that this was our matrix T. On the previous page, we had the matrix S2011. So you don't need to write them out again because this already established what these two matrices are. What we have to do is carefully put them into our calculators and get the right answer. So using your CAS, let's put in the matrix T first. All right, remember that you often, for bigger matrices, you've got to push the template button a couple of times. If you're a bit impatient, you might want to fast forward the next 30 seconds of me putting these numbers in. But this is definitely something that you need to do carefully in Saxon exams. It's easy to rush this because you don't want to take too long, but unfortunately it only takes one incorrect number to muck everything up. So type these in carefully. So there's our transition matrix. The matrix S2011 was 100, 250, 0. All right, and we've got our new matrix, which is 70, 170, 65, 45. 70, 170, 65, 45. And notice that this question just said, find the matrix S2012. So that's our answer. That is the matrix S2012. We've answered the question. Remember that in some cases you'll have to actually pick out some of the numbers in order to answer the question. Okay, so it says, find the expected number of operators at this site at the beginning of 2013. Okay, so this was the beginning of 2012, this matrix here. So for the beginning of 2013, we actually need to go one more step, right, in the transition matrix, which means we can just multiply by the transition matrix again, but a bit of a shortcut for that would be, if we want to multiply by the transition matrix twice, sorry, gone too far there, I can just go back to this previous calculation and put a power of 2 on it, right? Because that does the same job of multiplying the original matrix by the transition matrix twice. Okay, and so you can see we get 49, 143, 75.5, and 82.5. Now, this question's only asking for the number of operators, right? And the number of operators, remember, is the second number down, right? And you can go back to the previous matrix to kind of confirm that. I'm just trying to put that on the screen there. See that matrix S2011, how it's got A, O, P, L. So the second number is the number of operators. And so on the calculator here, we have 143 operators at the beginning of 2013. So in this case, we didn't have to write the matrix as our answer. We just had to identify one number from the matrix. We also have to find the beginning of which year the number of operators at the site first drops below 30. Right, so what we're looking for is like how many years into the future do we have to go before that second number drops below 30? So this is an interesting question. So after 2 years, right, we have got the number of operators is down to 143. After 3 years, it drops down to 119.3. After 4 years, notice all I'm doing here is just changing the power, because remember that's just now saying I'm going to go 4 years ahead of the first year, right? And as I keep increasing this power, that O number is dropping bit by bit. Now we need it to get below 30, so I might just take a shortcut here. I'm going to skip to say 7. Right, now after 7 years, I've still got 54 operators, so maybe I'll skip again to 10. Oh, okay, so 10, it was 29.38. So I'm going to have to sort of back up a bit here. Let's see what it was after 9 years. Okay, after 9 years, it was 36.229. After 10 years, it was 29.38. So after 10 years, that's when that number has first dropped below 30, because we've gone down to 29 operators at this job site. So after 9 years, it wasn't below 30, but after 10 years, it was below 30. So 10 years into the future is when this number first dropped below 30, right? And 10 years into the future, remember that our starting matrix was S2011. So 10 years into the future would be S2021. So it's at the beginning of 2021 that the number of operators first drops below 30. All right, so always answer in the context of the question. The answer is not 10, even though it took 10 years. The answer is 2021, because that's 10 years after the year that we started this thing from. Okay, and the total number of staff at the site in the longer term. Remember this, in the longer term, right? That's our indicator that it's steady state, right? We're looking for the steady state. In other words, if we go, 20 or 30 or 40 or 100 years into the future, that highlight didn't work, did it? Okay, well, you know what it means, it's steady state. So what we can do is we can, like I said, skip, say, 50 years into the future, right? And see what these numbers are looking like. Now, 50 years into the future, this is looking like I've got a really tiny number first, really small number of apprentices, really small number of operators. I've got 1.5 professionals left and 348 staff who have left. Now remember that in total there were 350 people, so this is looking like maybe everyone's going to leave. Let's just go 100 years into the future and see what it looks like. Okay, so I've got now such a super tiny number that the calculator can't fit it on the screen at the beginning. See how that says that E negative 14? That means I'm going to move this decimal place 14 spots to the left. So it's like 0.00000. It's basically 0. This second number again is like 0.0000. The third number is 0.00, and this last number is 349.99. Now, it's not quite there yet, but what it's looking like is going to happen is we're just going to get 0, 0, 0, and 350. You can try if you want to go further into the future and see if that definitely happens. I'm going to go to 200, but you can see that each time you increase this number by a lot, it has to think more and more. And from here now, we can see 349.999999. We're confident enough to say that certainly to the nearest whole number, what's going to happen is all of the staff are going to have left. And that makes sense because in 200 years' time, probably all these staff, they're not going to be hanging around anymore because they'll have moved on. Anyway, so the total number of staff at the site in the longer term is actually 0 because they've all left. Okay. Suppose the manager decides to bring 30 new apprentices, 20 new operators, and 10 new professionals to the site at the beginning of each year. So they're actually going to recruit new people to this job site. The matrix Sn plus 1 will then be given by Sn plus 1 equals T times Sn plus A. So we're going to add some matrix in this calculation, where S2011, still the same matrix, and A is equal to 30, 20, 10, and 0. So these are the new people that are going to get added in. Find the expected number of operators at the site at the beginning of 2013. Now remember, when you have a matrix equation where we're adding a matrix at the end, we actually have to work step by step. We can't skip ahead. So what we have to do is say, all right, well, let's find S2012, which will be T times S2011 plus A, all right? So we're going to work out 1 year into the future. Now the transition matrix is still the same, so you can use some copy pasting on your calculator here. So it's still the same transition matrix. It's still the same initial matrix, right? It's still, S2011 is still that 100, 250, 0. So I'm going to copy that one down as well. But this time we're adding this matrix A at the end, which is 30, 20, 10, and 0. All right, and so after 1 year, so for S2012, those are my values. I've got the matrix 100, 190, 75, and 45. Right, and so then S 2013 will equal T times S 2012 plus A. So you can see we're just doing one calculation at a time, 1 year at a time. And we can get that matrix by just repeating this calculation again. And again, we're going to try to be as lazy as possible using some copy pasting. So it's the transition matrix times S2012, which is what we just calculated, plus the matrix A, right? So don't type matrices in over and over again, just copy paste them. And so S2013, the following year, gives us 100, 182, 96.5, and 91.5. Now at this point, you're tempted to say that you've answered the question and you're finished, but you look carefully because the question's saying find the expected number of operators at the site. Remember, the operators is the second number, so there are 182 operators. Right, so always answer the question directly. Don't just leave the numbers in the matrix. Right, so 182 operators is our final answer to that question. Whew, bit of a long one, but as I said, always good to practice those tougher exam questions in the lead up to a SAC, and of course to help you for preparing for the end of your exams as well. All right, bye for now.